And I would like to invite Tracy Simpier to turn her camera on. And Tracy is going to be leading and facilitating our first stakeholder panel on marine operations and coastal hazards. And so, Tracy, I will let you take it over and introduce our panelists. Thanks, everyone.
Great, thank you so much, Kim. Good morning, I'm Tracy Simpier. I'll be facilitating the panel on marine operations and coastal hazards. We are very fortunate today to have Dr. Chris Fuller here with us, Dr. Tony Knap, Dr. Chunyan Lee, and Tuomo Saari, and we will be going in the order that you see on your screen. Just so that everyone knows, each presenter will be introducing themselves. Marcus will be running the slides for us. I will be timing each presenter, and I will turn my camera back on when there is 1 minute, and you will see a 1 minute time. And then when time is up, you will see me again with the stop sign. And then we will move to the next presenter. At the end of each one of our presenters today, we will have a discussion, and it will be based upon those 2 questions that Kim shared earlier today, which we will also place in the chat box. And so please, as the presenters are think about your questions, think about what you might want to ask. And again, we'll put those in the chat box for you to consider. Without further ado, I'd like to turn it over to Dr. Fuller so he can begin.
Good morning. Thank you all for letting me be with y'all today. Again, my name is Chris Fuller. I'm the Chief Operations Officer for Research Applied Technology Education. We're a small 501c3 with an office in Edinburgh, Texas. And I'm kind of presenting some work that we're doing on high frequency radar networks. We have networks operating in both Galveston Bay and Sabine Lake. So next slide, please. So just to give you a little bit of background on our HF radar project, again, we have a total of 5 HF radar stations, 3 on Galveston Bay operating at 25 megahertz, 2 on Sabine Lake operating at 42 megahertz. This project was originally funded by the General Land Office as a coastal management plan, cycle 27 project of special merit. And we started operation back in 2023 with real-time, with data going for real-time data vector processing through the GCOOS network. Then again, this project, we had CSOND assets, the CODAR assets that were originally acquired from the GLO back in circa 2000, late 90s. With Dr. Jim Bonner at the Blucher Institute. We're again able to put them back into service for the state with that CMP project with our project lead at UTEP, Dr. Rosa Fitzgerald in Lamar University. And at that time, we had some project partners that were really instrumental in getting our sites up and going. That was Galveston and Chambers County, the city of Port Arthur, and the Corps of Engineers, who all were helpful in getting us access to sites. With the GCOOS funding, that's the bill. I'm sorry, I get all my projects confused, but with the funding from GCOOS that Jorge helped us get, we're able to keep these stations maintained. So rates, our primary focus is a data provider and an operator of these assets to provide data to our stakeholders. One of our primary stakeholders at the moment is Texas Water Development Board. So the idea is that this data will help, them do their schism modeling effort where they need the data to address some of their data validations and stuff for their coast-wide modeling efforts. We also have some support through the Texas Integrated Flood Framework, where they've identified some data gaps on inshore wave measurements, where we feel like the HF radar could help fill those gaps as well. And for the, again, the Corps of Engineers, we work with them closely through some of our flood projects that we're working on up and down the Texas coast, where this inshore data could be very helpful for them in assessing, large assessing and design criteria of their coastal flood mitigation projects. And also with the General Land Office and some of our local emergency response agencies, we can help address some of those emergency response needs, like search and rescue operations and oil spill response. So next slide, please. So just some of the recent activities that the GCOOS funding has helped us, keep going is we've had to make some repairs to some of our transponders, our transmitters and receivers. Also some recent upgrades to our infrastructure, like GPS share modules. These are critical components. They're very expensive. A GPS share module is on the order of $14,000. So it's an equipment cost. We've had cables that we've had to replace, cable bundles. That's the type routine operation funding that this funding is helping us achieve. Again, also we need to do routine antenna pattern measurements. We plan our next round of antenna pattern measurements this winter. So just wanted to kind of give you an idea of what the GCOOS funding is being used for this project. Next slide, please. Okay. Again, it's going to kind of tell you, I think the idea of this presentation was to kind of tell what our stakeholders are. Again, rates is more of a data provider, an operator of these assets. So the Texas Water Development Board is one of our primary stakeholders through some of our bigger projects that we have with them along the Texas coast. We have a flood infrastructure fund project, and that's our main focus right now is flooding, inland and coastal flooding. So the Texas Water Development, their primary interest in HF radar current data is to support their coast-wide schism modeling effort. Again, that's to address for storms, to predict storm surges, salinity dynamics, and oil spill trajectory. I believe that the Texas Water Development Board actually develops the oil spill trajectory model for the General Land Office. Again, the Texas General Land Office, again, they've been a big supporter of ours in the past through the CMP program. Also, legacy support when I was back at Texas A&M at the Blucher Institute through all of our coastal work that we did. Again, the U.S. Army Corps of Engineers, they have an interest in this for a lot of their coastal mitigation plans for designing, major infrastructure, coastal infrastructure projects. More recently, the Texas Integrated Flood Framework. Again, that's a consortium of technical advisors we have that has representatives from General Land Office, the Corps of Engineers, U.S. Army Corps of Engineers, USGS, and a slew of academic advisors. So they've identified a data cap and nearshore wave data that's crucial for managing their coastal environments. That's something that they've identified. And they recognize that HF radar has the ability to measure nearshore waves. And that's something that we're pushing for, is for them to use this data source to fill that data gap. I think that would be useful for everyone involved. It's an asset that's deployed near not just mine, but all up and down the coast. The offshore looking asset should be being used as well. But anyway, we also see a need for those wave data to be validated. Offshore, where you have secondary measurements, from buoy type measurements, that's maybe simpler to do. Where it's difficult is in inshore applications like the bays, where we don't necessarily have good wave measurements with buoy measurements or wave radars or something. So that's kind of a challenge there. That's been recognized. Another thing that we'd like to do is to be able to assess the HF radar measurements under extreme conditions, and also evaluate appropriate HF radar operating frequencies for the nearshore wave measurements, recognizing that different frequencies are applicable to different wave environments, i.e. Period and wave heights. So, and again, other stakeholders, like Chambers County, they've expressed interest in our data to address some of their emergency response in the Bay, i.e. Search and rescue operations, or whenever they have a vessel go astray or what have you. So that's some of the data, the needs of our stakeholders. So next slide, please. I was asked to kind of present on what data we're providing. Well, with our HF radar stations at the moment, we're providing radial vector data from our 5 stations. Again, we have 2 stations in Sabine Lake, kind of capture the data for the southern end of Sabine Lake. And then we have very good coverage of Galveston Bay with our 3 stations, 1 at Smith Point, 1 at Beach City, up near the northern end of Trinity Bay, and then Moses Lake on the Texas City Dike. Next slide, please. We are testing wave data at our Sabine Lake, just in a test mode. Again, this was just kind of done as a demonstration. Within the next year, we're working to implement a more widespread application of wave data collection at all of our stations. Next slide, please. And how we applied the data. Again, rates is more of a data provider and operator of the systems. So it's been more of our project partners who have applied the data. With this particular project, again, Dr. Rosa Fitzgerald, that was the project lead at the University of Texas at El Paso, they did apply the data from our initial installation in Galveston Bay and Sabine Lake to do an initial validation of a schism model for the current data. So that's kind of where we were leading, but again, we still need to work with some more academic applications of our data. Next slide, please. So key findings and challenges from this initial installation. We've been in operation a pretty short time, and basically for the past year with the GCOOS funding. Prior to that, with the CMP, okay, I can wrap up. Where our current measurements on estuarine systems. And our challenges is just, again, to keep the system operating, under our harsh conditions. So next slide. Going to go ahead and stop, Tracy, or
could you just move maybe to the stakeholder slide real quickly, since that's what we're going to be discussing? That would be great. Thank you.
Like the stakeholder needs right here? Okay. All right. So the primary stakeholder needs that we have right now is really to fill the data gaps in the nearshore wave data that's directly applicable to the coastal environments, and also to be able to validate those measurements and to assess the wave measurements under extreme conditions. So that's where our stakeholder wants us to do right now. So.
Great, thank you so much. We really appreciate that, Dr. Fuller. And if you'll just be thinking about your questions, we can take those in the chat or in the Q&A. And now we are moving to Dr. Knapp.
Okay, put me up. We got Chris, not me. Hey, I'll go ahead and you can find me at some other stage. So this is a presentation from the Geochemical and Environmental Research Group, Texas A&M University. My background, I was director of GERG for about 11 and a half years after being president and director of the Bermuda Institute of Ocean Sciences in Bermuda. And people asked me why I came, and I said, obviously the weather. So that's where we are. So this presentation, Steve DeMarco is now the director of GERG, and there's a number of people that are playing an important role in this presentation, but I can't tell you that I think everyone that does observing knows that it takes an army of people to do it, or a village. Our chief partners right now, Texas General Land Office and the U.S. Coast Guard, and Brent Koza from TGLO might be online, I don't know. I don't have access to that. Also Christina Forbes from the U.S. Coast Guard. So our focus is on marine operations and coastal hazards. Next. So the project focus is we operate Texas HF radars. These radars were purchased by Texas A&M University through a chancellor's research initiative. I think it was about $1.8 million. The Texas Automated Buoy System, which has been going for almost 30 years now, which is funded by TGLO. Heat content with gliders, ocean heat content. And then the Tex LA regional model, which I don't know how many people know about, but that's funded by the Texas General Land Office and is run by Yun Liu. So for the HF radars, we have 5 stations in very, very remote locations. The 6th radar, Rollover Pass, was abandoned due to construction. And we're looking for a replacement. That's the most easterly radar. 6 buoys make up tabs. They're located in key conditions to provide real-time data for oil spill models. They also have many other uses, such as recreational and commercial fishing, etc. And they measure current, speed, and direction, and a wide array of meteorological information. GCOOS funds 1 to 2 missions for ocean heat content, hurricane intensity measurements. Main stakeholder of that would be the Hurricane Center. And the Texas LA model is used for oil spill, hypoxia, search and rescue, and many other activities. And so our main stakeholders, Texas General Land Office, U.S. Coast Guard, and the U.S. Hurricane Center. Next slide. This is just a visual of the sites and the currents go out about 180 kilometers. The furthest east station is Rollover Pass. That should be red. And anyone here who knows of a small patch of land that we could use to replace that site, we'd greatly appreciate it. Next. This is just an overview of the glider missions. This is a very interesting one that was funded by UGOS, but obviously the data is reported through Gandalf. And this was these couple of glider missions were present during the actual shedding of an eddy. So we were very fortunate to be out there. On the left bottom coast of Mexico, we operate 3 high-frequency radars there, which are funded right now by UGOS. Next slide. Texas Automated Buoy System, you can see the stations on the left. There are 6. This is the GERG TABS buoy family. We make different buoys for different locations and wind measurements. And you can see the size of the larger buoys on the back of that ship. Next slide. This is the Texas TGLO Texas LA forecast system, and you can see surface currents, bottom oxygen, and this is a 4-day forward-looking forecast. So, and it uses ROMS model as well as various validations from the buoys and other assets that we have. Next slide. So the type of data generated, the HF radar, current speed and direction in 6-kilometer resolution, about 180 kilometers from the coast, helps verify TABS data. TABS is current speed and direction in near real time, as well as MET data, and it's also verification of HF radar data. Buoyancy gliders, current temperature, 0 to 1,000 meters. There's some that are 0 to 200 meters, really collecting upper ocean heat content. That's the most interesting for hurricane intensity prediction. And the Texas LA model is a 4-day rolling forecast of temperature, salinity, oxygen, and currents. Next. So data application data is reported in near real time through web servers, web pages, tabs. Texas LA reported additionally through the TGLO website. HF radar is gliders through the GCOOS website and the GDAC. In the case of tabs, whenever there's an oil spill, TGLO used the data to calibrate oil spill models, as well as to provide an early warning of where to site oil recovery equipment or areas to protect by oil boom. In the case of the HF radars, GERG is working with US Coast Guard on data quality to eventually use in SAR events, that's search and rescue events. And the Texas LA model is interrogated about once a day by the Coast Guard to provide information for marine incidents such as search and rescue. You'll see a little bit more of that later on. Next. Key findings and challenges. The HF radar work very well when they work. And the challenges for us to find a new site at Roll River Pass that I keep mentioning, and I hope someone can help us. The challenge is to keep the radars operating. They're now 10 years old. Equipment fails, lightning strikes, need to replace, receive, and transmit amplifiers, which are very expensive. The GCOOS BIL has helped us. And vandalism is a challenge, as a whole radar trailer with all the equipment in it was stolen in July 2024. So I don't know who else is operating radar, but somewhere there's about $250,000 worth of equipment that was basically just taken away. And I should mention that thanks to Uchenna Nwankwo and Andy Dancer and others from GERG, that Surfside site is now up and running. And it took a while to get it that way because of power, etc., but it's now running. So, and that came online again last week. So tabs work as well, but requires regular maintenance. We're grateful to TGLO to provide funds for M&O. We're also grateful for the extra funds from GCOOS to add to some of tabs capabilities. The glider operations work really well, which is part of a larger GCOOS effort, as you all probably know, and Jorge has spoken about earlier on today. And the Texas LA model works well. It is used by a large group of users. And the forecast is useful because it's 4 days in the future. Next. Next slide. So this is slides from Brent Koza. Can you go back up one? So the stakeholder, the TGLO, for those that aren't in Texas, is the oldest agency in the state. It was established in 1836. Back then, the primary challenge was to keep records of maps, surveys, issue titles, manage the settlement of state lands. Today, the GLO is the state's leading agency in responding to coastal oil spills. Texas Oil Spill Planning and Response Toolkit is the most comprehensive oil spill preparedness and response tool available, providing ready access to contingency plans and environmental data, including tabs. The GLO real-time offshore spill tracking system that provides instant data to monitor spills and establish trajectories. Next slide. The stakeholder needs, TGLO needs real-time current speed and direction, and wind speed and direction in order to initialize oil spill tracking models. Specifically, tabs in the Texas LA model are funded by TGLO to provide this information to all users. Next. So real-time environmental models are plugged into various oil spill models, as I mentioned, and they're updated as data are received. Teams of responders are sent to specific coastal areas with predetermined vulnerability and then to deploy oil spill protection systems where needed. And there are a number of spills in Texas every day, small, but just waiting for the big one. Next. So the challenges are always keeping the system operating. Chris mentioned this. It's an incredibly harsh marine environmental conditions. Corrosion, sense of functionality, mooring security, fishing will play a role. And as TGLO needs a full set of working buoys, buoy failures are difficult and need to be replaced and repaired quickly. And you know, operating in this harsh environment is something I think everybody needs to understand to keep an ocean observing system running. Next. So this is from Christina Forbes. This is, I always am amazed when I see the slide that for search and rescue, that there are average of 4,432 lives saved each year, an average about 12 per day. This is around the United States. About 95% of these are within 20 nautical miles from the coast. And we've been working with Christina and her group for the last couple of years through GCOOS. She's been a speaker at our program. I should also mention that we also have a stakeholder group within the GCOOS program that I was the head of that working group. And we have a large list of oil company needs, recreational needs, etc., which I'm happy to share. Next. So current speed and direction, metadata, access to real-time model output. You can see the TAMU Texas LA model in the middle of the upper panel, and you can see all of the other models that they have access to. One of their big issues is the more regional models for inshore areas, which need some addition. Next. This is I apologize for this slide, but it'll be online. This is actually a really terrific list of the Coast Guard SAR requirements for environmental data. And it gives what is needed and the accuracy required and the timeliness. They have only hours to respond to an emergency. So it all has to be very accurate. Next. And this is the stakeholder challenges in the Gulf. You can see the whole of the Gulf area, especially Florida, and really the whole Gulf, where from January 2024 to December 2024, the Coast Guard had to react. Okay, that's the end of my presentation.
Right on time. That was great. Thank you so much, Dr. Knapp. And we are going to move to Dr. Lee.
Can you hear me?
Yes, we can.
Good morning. My name is Chunyan Lee. I'm a faculty member at LSU. I conduct research and teach for our oceanography and coastal meteorology programs. Thanks to GCOOS for the continued support over the years. And thank you, Jorge, and the staff at GCOOS for organizing this meeting. The title of the project is Continuing the Development of the Gulf Coastal Ocean Observing System. Our field technician is Brian Milan, and our IT expert is Dr. Peter Luo, who have been on this project with me through the years. Next slide, please. The main objective of our project is to expand, sustain, and advance the critical WAVES real-time observations of met ocean data along the Louisiana shelf and coastal waters. Our goal is to fill data gaps, better serve the community, and help disentangle how moving weather systems impact the coastal ocean, including storm surges, meteorological tides, shelf circulation, and help quantify land-ocean material transports. In our region, tropical and extratropical cyclones, as well as frontal passages, create repeated forcing that drive coastal hazards and the land-ocean exchange of carbon, nutrient, and sediment. Next slide, please. The type of data generated. Our station collect meteorological and oceanographic data for GCOOS and NOAA, and we also collect AeroNet ocean color data for NASA and NRL, which support the satellite calibration and validation of ocean color products. We have currently a couple of offshore stations. One of them is having real-time mid-ocean data. In addition, we also have just reactivated a real-time station at the Grand Isle, Caminada Pass for estuarine exchange flows. We record data every 5 minutes, and we send to us every hour real time. In addition to fixed stations, in the past few years, we also collect vessel-based data across the shelf. The idea is to repeatedly occupy planned transect lines to record non-aliased data to better resolve variabilities affected by tide, inertial oscillations, as well as weather impact. Next slide, please. So here we have a few examples of data collected. The left panel shows a snapshot of our station 6, which is offshore at 20-meter water depths. The data including meteorology data, wave data, velocity data. The right panel shows some flow velocity profiles on the shelf, which encompass several weather events. The center picture was taken just 2 days ago, shows our newly reactivated real-time station at Grand Isle as of November 11th, which is 2 days ago. Next slide, please. So in terms of data application, we're just giving some examples here for data applications. The data supports broad applications, including research and PhD dissertations on weather impact on coastal currents, water quality, sediment, and other material transport. For example, one application is to use observed data to calibrate a numerical model, FVCOM model, to simulate the impact of multiple inlet estuarine systems by storms. That includes Barataria Bay. In that experiment, we did simulation for 51 cold front induced storms. Another example is the impact of combined weather systems, a tropical system which made its landfall right over one of our real-time stations a few years ago at the Vermilion Bay, merged with atmospheric cold front so that they combine and turn into a strong extratropical cyclone that moved all the way to New Jersey, and along the way it caused historic flooding. Even though data is a few years ago, kind of old data, but we just published this year the result. Next slide, please. The key findings and challenges. Examples of those significant findings include, first, shelf water response to moving weather systems, showing that the non-aliased data reveals more subtle variability with rapid response to moving weather systems, particularly cold front passages kind of repeating every few days in the winter time, which alter the along shelf transport, for this example, 3 times in magnitude during a cold front, while the cross shelf transport remains kind of similar magnitude, just oscillating. And second example, model data study reviews that the storm-induced land-ocean exchange can be predicted by what we define as a cold front strength index. So the cold front come and go every few days, and we use a parameter a non-dimensional parameter to characterize the strength, and that appears to be a very good indicator. The third example is we proved mathematically a kind of a convolution theorem which provides a generic dynamic relationship showing that the ocean response is a superposition of linear superposition of several components. Each of them is a mathematical convolution between the forcing function, which is a complex function, a real number and a complex number. It's a specially defined forcing function like the wind and tide and so forth. The forcing function convolve, which is a mathematical mapping with the inertial oscillation function. And this convolution in digital signal processing is like, it works as a natural filter, which is kind of favors inertial oscillation. Major challenges that we experienced include sustainability issues, including maintenance costs, data transmission method and costs, and the ship time costs, which is ever increasing. And also, secondly, is vandalism. The middle picture is a buoy that we deployed this past summer, which only stayed for 3 days before someone took it. And third is the permit to access oil platforms. Next slide, please. The AeroNet Ocean Color Program is valued by Giuseppe Zibaldi, who is the creator of the AeroNet Ocean Color and the Sea Prism program. He works with NASA and the European Commission's Joint Research Center and has led the methodology for ocean color validation. David Camadel, who is the mayor of Grand Isle, gave us permit for us to install the real-time equipment at the Camadel Pass. The mayor's office is interested in accessing real-time data for local residents and fishermen. Next slide. There is still scarcity of stations and continuous mid-ocean data in coastal ocean that can help reduce marine accidents. One example is the tragedy of the capsizing of a 39-meter lift boat in 2021, which was due to a severe weather-induced high wind and waves, which was captured by our weather station at weather observations at our station 6. Next slide, please. So the data application for stakeholders include forecasting model usage, severe weather impact prediction and assessment, and satellite data validation for coastal waters of multiple states, material flux computation, which is of interest by colleagues and agencies, and local community usage such as fishermen and residents. Our needs include educating the next generation of other needs, include education of next generation scientists and citizens. The stakeholder challenges include sustainable data support for their usage and sufficient data points in the ocean. That concludes my presentation. Thank you for your attention.
Thank you very much, Dr. Lee. And just in case folks did not see, the presenter slides will be shared after the meeting in case we run short on time. I know we're trying to pack a lot, so just know that they will be shared. Our final presenter before we start our discussion is Mr. Saari.
Thank you. Yeah, I'm Tuomo Saari from GCOOS DMAC team. I've been with GCOOS for about 3 years now. This presentation is not a PI project presentation because the project, Sea Surface Height and Satellite Altimetry Data Project, PI is Dr. Leben from SEAGAR, but he wasn't able to prepare the slides for this occasion, so we hope that he can present at a later date. So instead, I was asked to present my part as GCOOS DMAC team member, what I'm doing on my end. So I'm not gonna present any of Leben's work because I wouldn't be doing any justice, just my part of the work. So next slide, please. Okay, I start with changes. So Dr. Leben actually during the past year or so bumped into several challenges with the changing data sets. He was using various satellite missions to compile us a data product that we would download from their CGAR servers. But as the data sets themselves kept changing, so he had to adjust and adjust. But eventually, what we now are using, he's using, and what we are as a result also using, are Copernicus Marine Service datasets. Two, one is near real time, and one is delayed mode, which goes all the way back to 1993 actually. And it's 1/8 degree altimeter satellite gridded sea level anomalies computed with respect to 20-year mean. And there's some additional variables, absolute dynamic topography and others. And we are actually using this ADT at GCOOS to publish data and provide other derived visualizations as well. Next slide, please. And as a result, well, there was a lot of headache, but as a result, actually, now that we have the near real-time Copernicus dataset, that enables, and also together with their download tool, it really enables daily and automated data flow, where I have scheduled tasks to download the data daily and then also to process it. Next slide, please. So what are the channels where this project publishes data at GCOOS level? So first of all, when the data gets downloaded, it's published as annual data sets on our ERDAP server, which now with the Copernicus new basically license, it allows a redistribution without added value. So that's where it goes first. This is just a picture of the ERDAP's graphing page. Next slide, please. And this project has a project website, which is the URL you can see there. Basically, on the left side picture, you can see the green buttons on the lower part, and that would just download the netcdf file for that year. And above those, you can see the sea surface height contours animations. So they produce daily sea surface height contour pictures and then just stitch them together as animations. And if you, Marcus, can click on the right side picture, it might be showing a little bit of an animation. I don't know if that's possible.
Yeah,
if not,
this is the PDF.
Oh, okay, sure. Next slide, please. And this just basically reiterates the data flow, which is now daily and automated, which just compared to the past, it used to be like monthly or so, where we would manually check if CGAR server would have new data. We would launch the script manually and so on. So number one, downloading the data. Number two, the ERDAP dataset refreshes automatically. And then number three, generating the sea surface height contour animations and publishing them in a web accessible folder. And then number four just shows that this project website, which actually runs on another server, links to those data on ERDAP and the web accessible folder. So this is now hands-off, and it's very different from the past. So this was all enabled by the change in the datasets that we use. And big thanks goes to Dr. Leben assisting me to get this workflow done. Next slide, please. There are lots of there's a lot of potential of added value here with much more data products and visualizations. Here, at the lower picture here is actually something that Dr. Leben puts together weekly and shares with the distribution list on Mondays, which is sea surface temperature data overlaid with the sea surface height contours. And the sea surface temperature data is from LSU EarthScan Lab. Credits go to Dr. Nanwalker and Mr. Alaric Haag, if I'm not mistaken. And the upper picture is my attempt at doing the same, but automated and daily. So again, overlaying the sea surface height contours. And you can see there's some differences that I still have to make improvements on my images, but it's already operational, but are not just published yet. Next slide, please. And this is kind of a big thing for GCOOS in general. So we have our own instance of ArcGIS Online platform where we don't compete for resources with other developers. And the picture here is very simple, just two data layers, sea surface height and the contours. And I was just testing how to import those when my Python scripts run daily, how to save them and import them to the ArcGIS Online platform. And we are really excited about this platform because it can potentially reach a larger and different audience, and it can, you can only imagine overlaying all sorts of data layers. It can enable quite interesting analysis. Could be a very useful tool for outreach and education as well. Next slide, please. And this is my last slide. One challenge for me, personally, just knowing what type of data products the community and stakeholders would be most interested in, then how to best present them and visualize them, and then automate this data flow of all these different data layers as feature layers or image layers to this ArcGIS Online tool as well. That concludes my presentation. Thank you.
Thank you very, very much. We really appreciate that. From all of our presenters, we really appreciate the time you take to help us understand the data that you've been collecting and some of the stakeholder needs and challenges. So now in our remaining few minutes in this session, what we would like to do is have an opportunity for everyone in our audience to ask questions or to get clarification on some of the things that were presented. We would also like you to consider the two questions that were posed earlier by Kim. And so we're going to place those in the chat box. But just as a reminder, that first question was, what is the greatest challenge or need for improving stakeholder application of observational data? And then the second, so let's start with that one. Let's just do this first one. And we already have a few questions that have come in. So for this first one, I wanted to ask Dr. Knap. The question is, for the SAROP list of requirements, does your team reach out to the Coast Guard and ask what they need? Do they come to you with a particular request, or is there some other way you determine how to support their efforts?
So Christina Forbes from the Coast Guard is online. Could we get her to answer that question?
Christina, are you able to take yourself off of mute?
Maybe I should answer it in the time we have. So the Coast Guard connection came through our working group 1 in GCOOS, where we reached out to a number of stakeholders about what their needs were. And Christina came to the last 2 GCOOS meetings and made presentations based on it. So it's only been a 2-year connection that we've made, but it's been very useful I think for both sides. So now we have a dialogue going on, and she's working with, Christina's working with Geochemical on our, the data quality needs. What the Coast Guard need is to make sure that the data that they're going to use for SAR ops is the best data it can be. And so data quality is incredibly important. And there's a 2-way street going on at the present time.
And Dr. Knap, it looks like Christina was able to get off of mute. Is that correct, Christina?
Yes, can you hear me now?
We can.
Okay. Yes? Okay. Yes, it's been great working with Tony and his group and Geochemical. Our biggest concern, since we use surface currents and winds to determine the location of the missing people or crafts. Our major concern is that the currents are accurate. And so having a validated and quality control high frequency radar data, it's imperative for us. So we have found in some areas that it wasn't, and that caused a great concern, but not in the Gulf, luckily not in the Gulf. So we're pretty confident about this data. I have worked closely with Uchenna from the University of Texas, and he has done a great validation of HF radar with our SLDMB data, buoy drifter data, which is self-locating data marker buoys. And so that has been a great partnership and has given us confidence about the data. We're also incorporating some of the new data from the HF radar from the Yucatan Peninsula that Tony has been the main person for this. So that has been great for us. We still would like to have a system of quality control of the HF radar all around the US so we can have great confidence in the data and not have to worry about, well, do I need to check other models or other observations to see this is correct? But this is not in the Gulf, so that has been good. And we also try to use a model that depends on is based on the HF radar, which is called the STPS. It's a statistical model that takes the high frequency radar from the past, detides it, dewinds it, and then projects it to the future because we need forecasts. So that's very important for us. So I hope I answered the question. Is there?
Yes, thank you very much. Thanks to both of you.
Can I make one addition? That there are now, with our Yucatan radars, very high quality data, but there are now models, ECOFs and TOPS, two models that are used, one used by industry, one not, that now assimilate HF radar data. And so for inflow of the water going into the Gulf of America at 28 million cubic meters per second, we have now models that can assimilate those data. So that's a big step.
Absolutely. Thank you for that addition. The next question that we have is really focused to all model panelists. Is model output archived and accessible to stakeholders, not necessarily a formal hindcast, but a collection of nowcasts that can shed light on historical trends? Do any of our panelists want to take a stab at that question? Again, is model output archived and accessible to stakeholders?
I can speak for the Coast Guard. All the models that we use, we sort of save them and archive it. So all the data, but it's mostly surface currents and winds. We archive them because we need sometimes to go back and check on a case, or we are asked questions about a certain case in the past. So we have everything archived.
Also, the Texas LA model is archived.
Thank you for that. This next question is for Tony or Christina. And the question is, are we meeting the full list of criteria for use of data for search and rescue operations?
Good question. Well, there is always more needs, unfortunately. Some are being met, some might not be met as much. Some of the issues that are coming up is we have this wonderful high resolution models along the coast, and when we have a case and we start using them, a very high resolution model, we're all happy using it, but the person might drift outside that model. So outside the coverage of that model, so we have to start using lower resolution models like HICOM or the Navy. So that causes an issue there because it doesn't. We have to start from the beginning with all the particles that drift and emulate the person and all the Monte Carlo simulations. So that's I would like the models to have more coverage in the Gulf. Like Tony showed the cases we had, they're all over the Gulf. So so that would be one issue. As I mentioned before, I like to see more high frequency radar validations, and those are the top things I can think of. One of the things that are important for us is also the top layer from the models. Like they have to be the top. We use the top layer of all the models because that's where most of our search objects drift, all the persons and vessels. So it has to be about 1 meter, that layer, and some models have them deeper. So they're not as accurate as we would want them to be, because if they're 10 meters, then the direction might be wrong, and the direction is very important because it makes us go over time to a completely different place to search. So that's a challenge we have as well.
Thank you for that. I see that Stephen Howden has a comment about marine operations. Stephen, are you able to come off of mute to make that comment? Stephen, if you're talking, we cannot hear you. Okay, so I'm not hearing Stephen, but Stephen, if you want to put that comment in the Q&A box. Okay, the mute button is not working for you. Okay, gotcha. If you would like to put that comment, and then we'll move on to the next question while we're working on that for you. So in these last few minutes that we have before our break, I'd like to ask if each panelist would like to give an example of how their stakeholders are communicating their outcomes resulting from data use. So example, Tony gave an example earlier about the numbers of lives saved, and that was a great example. Do others have an example that you would like to share?
So I mean, I can repeat myself, but I know that the Texas General Land Office require, you know, the data to run the oil spill models, and so we know that sort of works because they can go and get to the spill more or less before it reaches the coast. And of course, the buoys were really created and put in place and funded to be concerned about another Ichthyoc type spill where the oil came up from Mexico and coated Texas beaches. So.
Yeah, I would like to add as well that from our perspective, and from the GCOOS meetings and the GCOOS participation, there were some nice outcomes that are helping us. There were some, well, of course, what I said before, the incorporation of the HF radar in these from the Isla Conto and Puerto Morelos from Mexico into our SAROPS search and rescue optimal planning system now in 2026. It wouldn't have happened if I hadn't known about it, or we hadn't communicated, or so it has been a great outcome. Another outcome were some cameras that were put as well from GCOOS and WebCOOS from the University of Texas Marine Science Institute, and with our search and rescue sector Corpus Christi. They were installed in the University of Texas pier. So that's another great outcome. We have very happy with that. And of course, the work that Uchenna did with the validation of HF radar with our SLDMBs, it's very important work. And also the interactions with industry that we will be able to, they will be able to share one of their models with us for search and rescue. So the Woods Hole group. So that's another great outcome from this group and from all of what you do. And
I think I'd just like to add one thing. It's really difficult in trying to get stakeholder involvement. And we've been very fortunate through GCOOS to be able to get the oil and gas business, et cetera. And it's different between different operators too. And so, as I said, I can share offline the list of stakeholder requirements from various industries that we've gathered over the last 4 years.
Thank you both for that. I'm going to see if I can now voice what Stephen, since he was having a hard time coming off mute. This was his comment. For marine operations, a big development is the new electronic nautical chart, or ENC, standards that allow for environmental data overlays. This is a huge opportunity to reach marine operations stakeholders, and the new standards become legal in January with a period of several years of the old new standards being legal. The new standards will allow, for example, an overlay of surface current, which would be from HFR, GCOOS, and IUS, and needs to produce products in the new standards for ENCs. So thank you for that, Stephen, and I'm sorry we couldn't get you off of mute. So I hope that I relayed that okay. And then I do have one last question. We have about 1 minute here. I want to see if any panelists would like to comment on this. This person says, I understand that we have a healthy ecosystems panel next, but does this panel see a need to integrate biology and biodiversity EOVs into model forecasts and other real-time monitoring along with the physical and MET data?
In the case certainly of tabs, and that's a specific, they care about oil spills, current speed, etc. But they might care about biological impacts, certainly on the coast as far as an oil spill goes. But that's why the models are there. You can put anything on one of these buoys, any sensor, etc. But we have to find funding different than the mission-oriented funding from TGLO.
Great, well, thank you. That brings us to 11 o'clock, and we are scheduled to take a break between 11 and 11:10. I wanted to quickly ask Kim if there were any other announcements before we take that break.
I just wanted to thank all of our presenters and everyone for asking questions. This is very helpful information. Tony, I would definitely like for you to send that list of requirements that you were speaking of. And we will reconvene in 10 minutes and continue with our second panel on healthy ecosystems and human health and safety. Thanks again, everyone. See you soon.